Hello and welcome to the solutions video for assignments 5.05. So that's 5.05 numbers 1, 2, and 3. They are all based on, okay, if I can stop the zoom. They're all based on IXL 12-Y.7. And it's all about conditional probability. So what's the probability that A happens given B? That vertical line means given. Well, that means that we're only looking at all the possible outcomes where B is happening. So when we're doing our relationship, it's just B in our denominator instead of everything. And the numerator is A and B. So it's the union of the two. So what's the probability that we have both A and B given B? So another way to think about this, what's the probability that you have A and B? So A happens given B divided by the probability of everything possible. But because it's given B, we're only looking as the percentage of events where B has taken place. That's another way to derive this formula, which is not on the formula sheet. But this will be the key. So here, the probability that A occurs is 3/7. For B, it's 2/9. And A and B together is also 2/9. So what's the probability that A occurs given B? Well, that's 2/9 from here divided by 2/9 from here. So that's both. That's 1. This one is a little more clear. Probability of both is 3/5. Probability of just B is 4/5. So 3/5 over 4/5. That one simplifies to 3/4. So that is our probability here. Now, in this experiment, the probability that A occurs is 3/7, B is 3/5, and A and B is 2/9. So again, A given B is 2/9 divided by 3/5. So 2/9 divided by 3/5 is 10 out of 27. Now here, what's the probability of A given B where A and B is 3/8 and just B is 7/9? 3/8 divided by 7/9 is 27/56. And we have another unreducible fraction. Now again, still, what's the probability of A given B? That's 3/7 over 5/8. So 3 times 8 is 24. 5 times 7 is 35. No common factors, so it doesn't simplify. This one, 1/8 divided by 1/4 is the same as 4/8, or 1/2. Finally, a fraction that simplifies. Here, 3/7 divided by 5/6 is 18/35. Now we have 4/7 divided by 3/4. That is 16/21. Now we have something different. We see a different setup, just 2 numbers, not 3. So this time we're asked for the probability of both A and B given the other two. So here, it's our same equation. The probability of A given B is the probability of A and B over the probability of just B, which is probability of A and B, that's the probability of B times the probability of A given B. So it's just a manipulation of that formula to get here. So to find the probability of A and B, we take the probability of B and multiply it by the probability of A given B, which are just the 2 numbers we're given, 16/27. Same format, we just multiply the two together. 3 over 35. And again, we multiply these together. 10 over 21. Now, A and B, this is 12 over 49. Again, a different format. Now we've got the probability tables. So outcome is divisible by 2. The number 2 is the only one that satisfies A. And B, the outcome is prime. Again, that's 2. But B could also be 3. So the probability of A given B is 0.4 divided by 0.5. Because B could be 0.4 or 0.1, we add them for 0.5. 0.4 divided by 0.5 is 0.8. So now outcome is prime. That's either A or B, probability of 0.8. B is the outcome is a divisor of 2. That's 1 and 2. So outcome 2 is the only one that satisfies both criteria. So that's 0.6 for A and B, 0.8 for B. 0.6 divided by 0.8 is 0.75. Again, we are using decimals because they've provided decimals. So we have been given implicit permission to use them. So ideally, we're about half done. So A is the outcome is divisible by 2. That's either 2 or 4. B is the outcome is prime. That's 2 or 3. So 2 is the only outcome that satisfies both. So the probability of A and B is 0.1. The probability of just B is 0.5. 0.1 divided by 0.5 gives us 0.2. Now here, outcome is a divisor of 2. That's what our 2. And B, outcome is prime. That's 2 or 3. So the only event that satisfies both A and B is 2. So that's a probability of 0.2. Probability of all of B is 0.5. 0.2 divided by 0.5 is 0.4. Outcome is a divisor of 4. That could be 1, 2, or 4. And B outcome is a divisor of 5. That's 1 or 5. So 1 is the only number on both lists. The probability of A and B is 0.2. All outcomes, or all probability of B is 0.4 when you take 0.2 plus 0.2. 0.2 over 0.4 is 0.5. Now outcome is less than 4. That's 1, 2, or 3. And B is the outcome is less than 5. That's 1, 2, 3, or 4. So the probability of A and B is still just the 1, 2, or 3, which is 0.5. Probability of B alone is 0.8 when we add those together. 0.5 divided by 0.8 is 0.625. Now, the conditional probabilities here. Outcome is greater than or equal to 4, could be 4, 5, or 6. B is the outcome is prime, that's 2, 3, or 5. A and B then is just 5, or 0.45. And for B to be prime, that's 0.48. So if we have 0.45 divided by 0.48, that should be 0.9375. So it's the same as 15 over 16 is the simplification there. So now, A is prime. That's 2, 3, or 5. B is divisible by 2. That's 2 or 4. Probability of A given B. So probability of B is 0.1. But the only prime number that is also divisible by 2 is 2. So we have 0.08 divided by 0.1, which should just give us 0.8. Now here, let A, the outcome is a divisor of 2, so that's either 1 or 2. B says the outcome is prime, 2, 3, 5, and 7. So the probability of A and B is just the probability of 2, which is 0.046. The probability for all options of B is 0.46 plus 0.11 plus 0.046 plus 0.028. That works out to 0.2. Now here, A is the outcome is divisible by 2. That's 2, 4, and 6. B is the outcome is prime, 2, 3, and 5. So the only number which is both prime and divisible by 2 is 2. So our numerator is 0.09. Our denominator is everything that satisfies B, so that's 0.09 plus 0.502 plus 0.158 for the probabilities of 3 and 5. That all works out to 0.12. Now, a table gives a set of outcomes. So A is the outcome is less than or equal to 3. So that's 1, 2, and 3. B is the outcome is prime, 2, 3, 5, and 7. So probability of A and B is the probability of 2 or 3. So that's 0.223 and plus 0.27. That's our numerator. Our denominator is outcomes 2, 3, 5, and 7 added. 223 plus 0.27 plus 0.118 plus 0.114. For a total of 0.68. So now, outcome is a divisor of 5. That's either 1 or 5. And the outcome is prime, 2, 3, and 5. So the only point that satisfies both A and B is 5. So our numerator is 0.014. And our denominator is 0.249 plus 0.087 plus 0.014, which is 0.04. So the outcome is a divisor of 7, is either 1 or 7, and the outcome is prime, 2, 3, 5, and 7. So the only number that satisfies both is outcome 7, so that's a probability of 0.063 in our numerator. Our denominator is 0.19 plus 0.04 plus 0.057 plus 0.063, and that is 0.18. So here we go, number 26. The outcome is a divisor of 9. That's either 1, 3, or 9. The outcome is a divisor of 2. That's 1 or 2. So the only outcome that satisfies both A and B is 1. So our numerator is 0.028, and our denominator is 0.028 plus 0.022, the only outcomes that are divisors of 2. So this becomes 0.56. Now, number 27. The outcome is divisible by 3. That's going to be 3, 6, or 9. Outcome is prime, 2, 3, 5, and 7. So the only prime number which is divisible by 3 on this list is 3. So our numerator is 0.098. Now, the outcome is prime is the sum of the probabilities of having all the prime number outcomes. So that's 0.231 plus 0.098 plus 0.136 plus 0.025. So that all works out to 0.2. And here we go. Ideally, this will be our final question. The outcome is less than or equal to 7. That's outcomes 1 through 7. And the outcome is a divisor of 9. That would be 1, 3, or 9. So the probability of A and B are just the combined probabilities of outcomes 1 and 3. So our numerator is 0.061 plus 0.006, or 0.067. Our denominator is all possible values for B. So that is our numerator 0.061 plus 0.006 plus the divisibility by 9 itself, 0.067. So this works out to 0.5. And that concludes the solutions for IXL 12 Y.7, which is our assignment 5.05.